Okay, so going through an example on how to solve trigonometric ratios, but this time when they involve double angle identities. And you could have gone around with it previously by manipulating the domain or something, but we do want to avoid that we just want to use the identities here. So what we have is sine 2 theta equals root 3 cos theta. So I can rewrite this left-hand side by using the first identity. So I have 2 sine theta cos theta equals root 3 cos theta. Now there are two solutions to this, and we need to be careful here. So I'm going to deal with the first set of solution, and then I'm going to come to the special case. For now, it seems like, oh, I could divide by cos theta. So I'm going to do this with caution. We are going to divide by cos theta, but this is only one case. So then I'm left with 2 sine theta equals to root 3. Sine theta is equal to root 3 over 2. And this is telling me sine is positive, so I'm in the first and second quadrant. My answers have to be there. Using the exact values table, I should know that theta is pi over 3. And because I want in the second quadrant, I will go and do pi minus pi over 3, and that will give me the other angle, which is 2 pi over 3. Okay, so straightforward there. The other case you need to be careful of is whenever you're dividing anything on both sides, you need to be careful that you're not dividing by 0, and this goes in any algebraic operation you're doing. You need to be careful you're not dividing by 0, especially when it's like a function or an expression. Now cos theta can be 0, which is why by dividing cos theta on both sides, we're unconsciously eliminating one or more solutions. So when is cos theta equal to 0? Because if cos theta is equal to 0 here, then cos theta is equal to 0 here, which means I get another solution. These two will be equal. My whole goal is to make these two equal. So if cos theta is 0, cos theta is 0, then they're equal. So meaning that if I can find out when is cos theta equal to 0, that's another solution. So what I'm going to do, I mean, there's another way to explain this algebraically, but this is a straightforward way to do this. You can, yeah, you could do this differently, but anyways, so just be careful not to divide by 0. So when is cos theta equal to 0? This happens when theta is pi over 2. Okay, so that's 90 degrees. But it also happens when it's 3 pi over 2, and these are cases you should know of. So in the unit circle, you have your coordinates as 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Now, remember that cos is your x coordinate. So at cos equals to 0, cos is equal to, at cos 0, angle 0, cos is equal to 1. At angle 90, or pi over 2, cos is equal to 0. At angle pi, or 180, cos is equal to negative 1. And at angle 270, or 3 pi over 2, cos is equal to 0. So this is where it happens. So also part of the special exact value. So these are your other values. So in total we have 4 solutions. We have 1, 2, 3, and 4. The next video I'm going to go through another example, maybe not with a special case like this, but again dealing with solving trigonometric equations.